Okay, ladies and gentlemen, our third and final installment of finding the area of a triangle on a coordinate plane. Now, this is going to be the box method. Now, typically this is used for scalene triangles, but I have to say, this box method will work really for any type of shape or figure on a coordinate plane. It'll work for any triangle. Okay, but typically we use it for scalene since we can't use either one of the other two methods. So in order to use this method, right, it's a scalene triangle, we want basically this yellow area, right? So we'll put this triangle in a box. Basically, we're going to surround this triangle exactly or perfectly in a rectangle. Each of the, here, look, if you notice, each of the vertices, all three vertices are on the rectangle. Find the area of the rectangle by using the rectangle formula. Area equals base times height. I think I put length times width, same thing. So you'll find the area of the rectangle, but guys, that's going to be too much area, right? Notice there's extra spaces out here. What we're going to then do next is subtract the area of the extra pieces around the triangle from the area of the rectangle. So we're going to have the rectangle area, and guys, I usually number them as 1, 2, 3 pieces. So we're going to have rectangle area minus the area of piece 1, minus the area of piece 2, minus the area of piece 3. Be sure to show your work, simplify your answer, and label your units with units squared. So down the bottom here, okay, and also this document will be posted, but we're going to have length times width will give us the area of the rectangle. Then we're going to subtract each of the three pieces. Now, ladies and gentlemen, it's also important to note that each of these pieces will be right triangles. So we're going to have length times width, which is the area of the whole rectangle, minus the area of triangle number 1. So I just put 1/2 BH minus 1/2 BH minus 1/2 BH. Let's give it a shot. So what I'd like to do is I'm going to choose one of the questions from our extra practice review posted on Google Classroom. Okay, so I'm going to go up top here. All right, this is example number 5. All right, triangle ABC. Now, if I zoom in on this table very quickly, we have 3 different side lengths. That makes this scalene. We do not have a pair of opposite reciprocal slopes. Therefore, this triangle is not a right triangle. So how will we tell? Well, we'll use our Pythagorean theorem. Again, you can check all these answers out on Google Classroom. I'm just trying to speed this up for a shorter video. We end up getting a c squared value that is too small compared to a squared plus b squared. Therefore, it is an acute scalene triangle. All right, I've also taken the luxury of drawing this figure, and now I need to focus on this, all right? This is really, really important. I've drawn my rectangle around triangle ABC, and if you notice, all 3 vertices lie on the rectangles, perfectly surrounding it. I've also labeled this with part 1, part 2, or part 3, or piece 1, piece 2, piece 3. We now need to figure out our dimensions. Now, we should use our coordinates. So point C is located at 0, 9. Okay, so that means C is 9 units above the x-axis. Point B is located at 4, negative, oops, not negative 16, my bad, right? That's 4, negative 6. So now think about it, 6 below the x-axis, it's 9 above. That means this entire length is 15, okay? Let's go down the bottom here. Let's find this bottom length. Point A is over here. Point A is located at negative 7, negative 1. Which means, think about it, guys, point A is 7 units left of the y-axis, right? Negative 7. 7 units left of the y-axis. Point B is 4 units to the right of it. So 7 left plus 4 right is going to give us a length of 11. Okay. Now, we got to keep going here, right? And I'm going to try to highlight this a little bit here, right? So this length right here, and I'm going to use a different color, and this length right here, right? The yellow and the green together should add up to 15 on the other side, right? It's a rectangle. So let's see what happens here. So we are, let's see, let's do the vertical part of this. So let's think. So this is 9 units above the axis, and this point is 1 below. So think about it. 9 to get down to here, and an extra 1 would make 10. Okay, now think about it. If this whole side length is 10, I'm thinking this is 5. Okay, so 5 here, 10 here. All right, and if I just check, 1, 2, 3, 4, 5, we're all good. All right, I have everything labeled with what I need. Okay, let me back out a little bit. Here we go. All right, I'm going to start to find the area of this triangle. Whoops. All right, so here we go. The first step is to find the area of the full rectangle. Okay, the full rectangle is 11 by 15. So I'm going to write that down here, 11 times 15. All right, good. So let's keep it moving here, right? Well, maybe we'll just do that real quick, right? 11 times 15 is 165. Now, minus. Here we go. Piece 1, which I have up here. Oh, and I forgot to break this part up on top. Whoops, let's do that real quick. So we should know that this is 11, right? So this is 1, 2, 3, 4. So that's 4 units. And then this is 7 units, okay? All right, here we go. So piece number 1 is a right triangle. Maybe I'll just add my little box there, in which the legs are 7 and 10. So in order to find the area of this right triangle, I'm going to do 1/2 times 10 times 7, or vice versa. 10 times 7 is 70. Cut in half is 35. All right, so right now we have 165 is the whole rectangle. We're going to subtract 35 for piece 1. Now let's go to piece 2. Okay, piece 2 is a right triangle that has a base and height of 11 and 5. Okay, so that's going to be 1/2 times 11 times 5. Now 11 times 5 is 55, right? Times 1/2 will be 27.5. Okay. Our last piece is piece number 3 over here, and this is 4 by 15, right? So length and a width, or the two legs are 4 and 15. 4 and 15. 4 times 15 is 60. Cut in half is 30. Now, ladies and gentlemen, I just grab my calculator. I take 165 minus each of these 3 extra pieces. Our final area will be 72.5 units squared. Okay? Now down the bottom, our perimeter is just going to be the sum of the 3 side lengths. Since all 3 side lengths are different, we're done. That's a wrap. Ladies and gentlemen, I hope this helps. Please reach out to me with any questions. Go to Google Classroom for all your documents and answer keys and helpful videos. Good luck.